Right, so we're going to look at modular inequalities. So this is going to be a step on from the linear and the quadratic inequalities that we looked at in the previous section, and moving on a little bit more from our modular equations that you've been looking at in the previous class. So with modular equations, we've kind of established that these two lines mean the modulus. That modulus is the positive value of whatever is between those two lines. So if we had, say, -6 between the two lines, the modulus of -6 is going to be +6, always just finding the positive value of those. So what we're going to do now is extend that to our inequalities and see how this modulus plays into these inequality questions. And we have a number of different methods for solving them, a lot of them coming from the same methods we had for doing the equations. We're also going to see a similarity between solving these modulus equations and solving the initial inequalities that we had in the previous section as well. So if we're able to do those, all that we need to work on is setting up these modulus equations so that we can get to a point where the questions look the same as the ones in the previous section, and then we should already be able to solve those. So it's only a little step on from what we had originally. But it's just making sure we have a good understanding of what this modulus means, what it is, and how we can use it to solve these questions. So let's just look really quickly at one of these definitions, I suppose. So if the modulus of x is less than 1, if that's our inequality question, then we can say that x must be between +1 and -1, i.e. that we can write it like this. Okay, that we can write it as -1 is less than x is less than 1. And the reason that we can do that comes back to this definition of the modulus. So we need to rethink this. The modulus is the positive value of whatever value of x we put into it. So what we want is that the positive value is less than 1. So if we think of our number line, for a second, so here we have, let's try and take maybe a half here and 1, and here we can do -1/2, -1, might do -2. Okay, not completely to scale, but just for our own example here, it'll work. If we were to take, for example, this value here of 1/2 and do the modulus of 1/2, we would get still 1/2, which is less than 1. Okay, and we can see that we'd be fairly straightforward with the plus values. It's more the negative values that we have to kind of think a little bit more about. So we want to take a negative value of x such that when we take the modulus of it, the positive value is less than 1. And we might be inclined to think, oh, it's going to be ones that are on the other side of -1, so say -2. And we try -2, and we take the positive value, and we get 2. So 2 obviously is bigger than 1. So we can see we've made a mistake there. So instead, we try the other side. So we try the other side, we take -1/2. If we take the modulus of -1/2, that's going to be +1/2, which is less than 1. And what this means for us is the values which satisfy this inequality, the values for which the modulus of x is less than 1, are those numbers between 1 and -1. Any number between those two numbers on their number line will give us a value that's going to be less than 1 when we plug it into that modulus. Okay, so it's just worth knowing that if the modulus is less than a number, we're going to end up with an inequality like this one here. So a continuous inequality, and it's going to be all the values between 1 and -1, for example. If we have one like the one below here, where it's the modulus of x is greater than 1, then we say that x must be bigger than 1, or x must be smaller than -1. And again, we can get this into our head by trying out some different values. For the first part, the x is greater than 1, that part's fairly straightforward. Obviously, the modulus of a positive number is just the same number, so we can see that fairly clearly. But obviously, as the numbers are bigger than 1, the modulus will also be bigger than 1. For the negative values, we need to think again about what it means. The modulus of a negative number is essentially just taking the number without the sign. So if I take -2, -3, -4, the modulus of all these values is just going to be 2 or 3 or 4, and those will all be bigger than 1. So x is greater than 1, but less than -1. And we can kind of see a trend here where for the negative numbers, the inequality sign is nearly the other way around from what we're given in the question in terms of x. Okay, it's just worth kind of keeping that in mind. So generally for the negative signs, our inequality sign is the other way around. So we can see that there, where the first one for the positive values follows the same inequality sign. For the negative values, the inequality sign is the other way around. Okay, so we can kind of stick with that general rule of thumb, I suppose, and if we take maybe a note of that. So for the negative values, inequality is flipped, and it's just a general rule of thumb to help us understand it. So when we're solving these questions, we can solve them graphically or algebraically, as we did with the modular equations, but also as we did with our linear inequalities and our quadratic inequalities. So we're going to look at this example first, and we're going to try and do it algebraically to start. So looking at it algebraically, we have two different ways of doing this. The first way is going to come from what we've said in the first half, and we can see that this modulus of x minus 6 has to be less than 2. And what that means for us then is that the value of x minus 6 must be less than 2 or bigger than minus 2. Either of these satisfies this modulus inequality. So it means that the inside, the x minus 6, has to be either smaller than 2, because it's a positive value, or it has to be bigger than minus 2, because any value bigger than minus 2 inside that will give us a modulus that is smaller than 2. Okay, so we work then to solve this inequality. So the way that we've solved these before was to take them and split them up. So let's take this purple side first. So minus 2 is less than x minus 6, and then we get that x is going to be greater than 4. Okay, if we take then this blue part here, we'll do it over to the side here. So x minus 6 is less than 2, and we get that x then must be less than 8. And if we put those together, x has to be less than 8, but greater than 4. And we can try that out for ourselves. We can kind of have a look. If we plug in 8, we get 8 take away 6, and that'll give us 2. But if we try the 4 take away 6 is minus 2. The modulus of minus 2, again, will give us 2. Okay, we can see those inequality signs kind of tell us these extreme values for which this will work. So if we try our other algebraic way, and we should remember this from the last section, so we're saying x minus 6 is less than 2. Okay, so we're going to start off by squaring both sides. So x minus 6 squared is less than 2 squared. We multiply this out, and again, making sure that you're just being consistent with multiplying out your brackets. So we have then x squared minus 12x plus 32 is less than 0. Okay, so then we can let this equal to 0. To solve it as a quadratic, we're looking for two numbers that will multiply to give me 32, but that will add to give me 12. So we should be able to see that those two numbers are going to be 4 and 8. We jump straight to our brackets, x minus 4, x minus 8. And it means that x is equal to 8 and x is equal to 4. Then from what we've done previously with our linear inequalities, we should remember that at this point we can draw our sketch of our graph to see what part of our graph we're going to be looking at. So again, just a sketch, just to give us a general idea. So to see which part of our graph we're looking at, we go back to where we've had the quadratic with our inequality sign, and we can see that we have written down less than 0, and our graph is less than 0 when it's below the x-axis. So to write out our final answer, we're going to have x being less than 8 but greater than 4, which is obviously a match for what we had originally on the left hand side here. So we can see that either way we do it, we end up with the same answer. The right hand side can seem more time consuming, but it also may seem a little bit more straightforward for some people because we're following similar techniques to what we did for the previous section. So if you're comfortable with the first way, you're more than welcome to do that. If you want to just be really, really sure, you might like to follow the second way, particularly given that we saw the questions with the modular equations where we had a modulus on both sides and we were left with those questions that we had to square both sides. So we want to leave ourselves comfortable doing all these methods. If we give it a go graphically, we, from the last class, should remember if we draw out a sketch of our graph, so we need to just make sure we remember our equations. So we're doing x minus 6, the modulus of x minus 6 is less than 2. So let's first of all just look for the point where f of x is equal to 0. So where the modulus of x minus 6 is equal to 0 is going to be when x is equal to 6. So let's not waste any time. So this is going to be our first point. Let's pick a point either side. So if we pick the point 5, we get the modulus of minus 1, which is 1. So at the point 5, we're going to have, and we'll maybe put 1 here, here. And if we go the other side, we should know from yesterday, or we should expect that we would get the same again. And 7, the point 7, 1 is also on the graph. And then we just connect those lines up to get a sketch of our graph. Nice and straightforward. And we have our nice V-shaped graph there. And obviously it's quite narrow with the way that I've just drawn the axes, but that's perfectly fine. And what we're looking for now is where this graph is less than 2. And we should remember as well, all these things, where the graph is less than 2, where f of x is less than 2, where y is less than 2. So I can draw my line across here at y is equal to 2. Okay, as straight as we can. And then we do our nice markings down. And we can kind of estimate that we're expecting around about here or here, which is the points 4 and 8. And what we've been asked is, where is our graph below 2? So we're looking at where is our graph below this line. And we can see that that's this whole yellow section here, and that yellow section is between the points of 8 and 4. Okay, and again, same answer that we've had for the last two parts as well. So we can see 3 different methods there, but each of them giving us the same answer. And we just have to be comfortable doing it both graphically and algebraically. Obviously, we had 2 different methods in terms of the algebra, and that's completely fine, but we should be comfortable doing it either of these ways, either an algebraic way or a graphic way, because depending on the question, we might not have a choice. So we need to make sure we understand both of these ways. If we have a look at another question, so we're asked to sketch the graph of f of x is equal to 2x minus 5 and hence solve the inequality. So let's do a sketch of the graph. So first of all, we'll see where f of x is equal to 0, and that's going to be when 2x minus 5 is equal to 0, which is when x is equal to 5 over 2. So if we label out our axes here, so say this is 1, this is 2, 3, 4. This first point is 5 over 2 is this point here. So let's pick a point either side. Maybe let's pick the point 2. So if we sub that into our graph to see what value we get, and we're going to get the modulus of 1, which is 1. Okay, so let's say that's here. So labeling my axes as I go, and let's maybe pick the point 3 as well. And we should, again, already expect what our answer will be, and we're correct in thinking that it's 1. Once we have our 3 points there, we just need to connect them up to get our V-shaped graph. And obviously, if you like, you can obviously do more points, but once you have 3, you should be able to draw a fairly clear sketch of your graph, of what we would expect. And our inequality then is to solve 2x minus 5 is less than 3. So we go to the point where y is equal to 3, we draw our straight line across, and then we're going to draw our straight lines down to see where they meet the x-axis. And kind of roughly here, I'm thinking around about 1.25 and about 3.75, around about. So if I was to write down my answer, I would expect that the modulus of 2x minus 5 is less than 3 for x between 3.75 and 1.25. Okay, Okay, so that's what I would expect my answer to be. And laying it out there nice and clearly for an examiner that they can see what I'm giving the answer as. And we should be able to follow that quite clearly. We can see it's the points below here, and I've marked in all those points on my sketch, and those will all again pick me up graphs, or pick me up marks, pick me up graphs. So that's something to watch out for as well. If we're doing a question like this, leave in those markings, because that's somewhere you can pick up marks as you go. Even if you haven't got fully to the answer, if you've shown that you've sketched your graph, if you've drawn your line across at 3, those are all points where you'll pick up marks. Okay, so that's an example of a question where we're actually not asked to do it algebraically. Let's just try another example here, slightly different, where we're given two different moduluses, and we're asked to solve this inequality that has two modulus in it. So x plus 3 and the modulus of 3x minus 7. We're asked to do it both algebraically and indicate graphically the solution set. Okay, so first of all, we're asked to draw a graph of both of these. So let's start with that first. So if we do x plus 3, we're going to start with this. So let's first do where f of x is equal to 0, and that's where x is equal to minus 3. So if we pick this as minus 1, minus 2, minus 3, 3, 4, 5, 6, 7, and on and so forth. So let's just mark in one of those points. So x is equal to minus 3 here. Let's pick another point then. So maybe we'll do one either side as we generally do. So we're thinking for minus 4. Minus 4 plus 3 gives me minus 1, the modulus of minus 1, which is plus 1. Okay, so that will be here. And of course, we should be fairly confident on what the value is going to be. If I do the modulus of minus 2 plus 3, it's the modulus of 1, which is of course equal to 1, and what we would expect. And we can draw in our graph for this one, sketching it in using my straight lines, and again keeping it nice and straightforward and getting that nice V-shaped as best we can. So let's try our other graph then, our 3x minus 7. So we start off again finding the roots, so finding where it's equal to 0. 3x minus 7 is equal to 0 when x is equal to 7 over 3. Okay, let's then go, so 7 over 3, we're thinking about 2 and 1/3, so maybe around about here. Okay, so we'll say about that point there, and let me just color it over in blue. Let's try another point. So we can pick any other point at all, it doesn't really matter. If we try the point 2 maybe, so let's try 3 by 2 minus 7, we get the modulus of 6 minus 7, which of course is the modulus of minus 1, which is 1. So for the point 2, we're expecting our graph to be around about here. Okay, if we try another value, let's maybe try the value for 3. So if we go 3 by 3 minus 7, and this is a good one to see because it's slightly different from what we've had already. Modulus of 2, which is 2, because our answers aren't actually lining up in the same way that we've seen in the other questions, but that's okay because we're not actually picking the ones that are entirely symmetrical with the same way that we've done with the other ones. Because of the way we've labeled our axes, we can see that they're not entirely lining up here. Okay, so let's just extend, just on my own diagram here, I want to just extend out this graph just so we can make it really explicit for ourselves. We can see that there is a point where the two graphs do cross over, and that point is this one here. And we're asked to solve the inequality where x plus 3 is less than 3x minus 7 algebraically and indicate graphically the solution set. Okay, so if I was to say algebraically, I'm going to take my two moduli here, 3x minus 7. Okay, I'm going to start off by following the same rules that we did when we solved these questions. In terms of equations, we're going to start off by squaring both sides. Okay, and again, as we said in the last task, making sure that as we square both sides, that we are actually following through with squaring those out, that we're not simply just writing it down and then treating it like our square roots from before, that we actually need to follow through and square out those two sides. So let's see, 7 sevens are 3, okay, and or not 63. Nope, 49. There we go. Okay, so let's go 0, and we're just tidying it up a little bit. 8x squared minus 48x. Let's go over plus c plus 40. Okay, and we can divide across by 8 and make things a little bit easier for ourselves. Minus 6x plus 5 is greater than 0. Okay, so let's continue down and solve this quadratic. So if we let it equal to 0 so that we can solve, we get two numbers that multiply to give me 5 but add to give me minus 6. So obviously we're going to get x minus 5, x minus 1, which means x is equal to 5 or x is equal to 1. Then to see where our solution set is going to be, we look back at our quadratic here and our inequality sign that we had with it. We can draw our sketch like we've done many times with those questions in the last few classes, and we're looking at these extreme values on the side here. Okay, so between 1 and 5. And let's just write down, so if we go, or not between 1 and 5, sorry, on the outskirts. So we're saying when x is less than 1 and when x is greater than 5. Okay, so we can see then how does that relate to our graph that we have here. Okay, and it's hard to see on this graph that I've done because the points are quite small and because of how we've kind of drawn the graph. But if we extend these lines even further through the question, just to give us a look at some of the more extreme values, I suppose. So let's just extend these lines even further. Okay, so we are looking to see where x plus 3, which if we're not clear, x plus 3 is the red graph, where that graph is smaller than 3x minus 7, which is the blue graph. So where is the red graph smaller than the blue graph? And we can see that up to this point here. So following up this graph, here the red graph is smaller, and at this point where they cross over, from that point on, the red graph is actually above the blue graph, and it's above the blue graph up until they cross here again and continue on this way. So our solution set is going to be, as we've got there, anything below 1, and if we follow on from here, so obviously it's not incredibly accurate because we're slightly off with our sketch there, but we can see even the numbers that I've drawn in are slightly off. But following our solution here, we can see that our answer is going to be for x that are less than 1 and x that are greater than 5, and following it through that way. And we can see how solving that algebraically was a lot clearer than trying to solve it graphically, because our graphic solutions are very dependent on the graphs that we've drawn. Okay, particularly for a question like that where we have kind of 2/3 and things like that going on. But it's also good for us to see how these questions can become really similar to our inequality ones that we've had previously. So we've already seen these inequality ones and how we can sketch out a quadratic and work out which part of a quadratic we're looking at. And we can apply the same thing to our modulus questions. So if we have those ones under control, the hardest part is just getting us to that. And that was all this step here, making sure we were squaring both sides. Let's just look before we finished up one more example, and that's going to be this one here. We can see that this inequality has two parts to it. So it's where the modulus of x plus 3 is between 2 and 6. Okay, we're going to solve it two ways, so let's do algebraically first. So we might split it up. x plus 3. Okay, let's square both sides. So we're going to get 2 squared is less than x plus 3 squared. So 4 is less than x squared plus 6x plus 9. Let's tidy it up a little bit more. So x squared plus 6x plus 5 is greater than 0. I'm looking for two numbers that multiply to give me 6 and multiply to give me 5 and not to give me 6. So again, it's 5 and 1, similar to the last question. We have x is equal to minus 5, x is equal to minus 1. And doing our quick sketch of our graph. Okay, we can say this one here is minus 5, this is minus 1, this is minus 5, and we're looking for the points where it is greater than 0. So that would be for all these points here. And we can write that underneath. It's where x is less than minus 5, where x is greater than minus 1. Okay, but we're not finished yet because we have to take the other half. And the other half was x plus 3. The modulus of x plus 3 is going to be less than 6. We're going to do the same thing again. We're going to square both sides, which will give us x. The same thing here, a 36 on this side. Again, we can tidy up a little bit more. And we can bring this over to the other side and get a minus 27. Okay, get a minus 27. So I'm looking for two numbers that will multiply to give me 27, but that will add to give me 6. Okay, so we should be able to see that that is going to be x plus 9 and x minus 3, which means that x is equal to minus 9 and x is equal to 3. Okay, and then looking at our solution set here, we're less than 0, so we have that x is between 3 and minus 9. So when x is between minus 9 and 3, our value of that modulus is going to be less than 6. Okay, and that does make sense there. So now we've got two different solution sets, and we can label both of these. We can maybe call the solution set A and solution set B, and what we want to look for is where is A intersection B. So where do the two sets? So where do the two solution sets meet? So where do the two solution sets meet? Okay, so if we want to have a look at that, we could look on our standard number line, okay, which is what we'll do. So let's say this is minus 10, minus 9, minus 8, minus 6, minus 5, minus 4, minus 3, 1, 0, 1, 2, 3, 4. Okay, so let's look first at this point here. So we'll do, let me give me a color here. We'll do this one here first, solution set B. So solution set B is between minus 9 and 3. So we're going from between here to here, quite a wide berth. Okay, and anywhere along here, the values of x satisfy our equation. We can then look at the other examples. So maybe I'll use this green color here. So the green color was when x is less than minus 5. So that's going to be, maybe I'll just draw it above here. So that's going to be anywhere down here. Okay, and when it was bigger than minus 1, anywhere bigger here. Okay, so what we want to look for is where these two solution sets are both satisfied. And we can see that they're both satisfied at this part here and at this part here. Okay, quite a smaller section. So those are our two answers we're going to write down. So first of all, when x is between minus 5 and minus 9, and then also when x is between 3 and minus 1. And these are our two solution sets. So when x is between minus 9 and minus 5, the values satisfy our equation, and also then when x is between minus 1 and 3, the values of x satisfy our equation. Okay, so we can see there that the question we started with has a nice lovely two-sided thing, and that actually leads to us having two different solution sets, or I suppose 4 different solutions that we had there that we then have to put together. The hard part can be this last step here, working out where are the values where these are both satisfied. So these are the sort of questions that are really worth practicing over, these particular ones with the double-sided, with the kind of less than on both sides for our modulus inequalities. But if we can get a hang of all of these different aspects, so looking at our algebraic ways of solving and our graphic ways of solving, okay, making sure that we understand how to do them, that we're able to attempt those starting questions in the book exercises, and then pushing ourselves that little bit further. Okay, but these are kind of just, I suppose, examples of the different type of questions that can come up. This can be one of the more tricky ones, I suppose, at the end here. Some of the ones with graphing here can be quite hard as well. We've seen here that it's worth just making sure that you're confident with your graphing skills, that you're giving yourself enough room to graph out the question as best you can and follow through that way. But otherwise, it's just making sure we're comfortable with all the different ways of doing these questions.